What's up, everybody? We're going to give some time, about another minute, so other people can log in with us. Happy Monday. Hopefully, you all had a fantastic weekend. Let me give the thumbs up if you had a fantastic weekend. All right. What's up, everybody? I'm glad people had a great weekend. Very, very good. So let's start out with our warm up. It says, what is energy and where does it come from? So if you think you know what energy is, please type it in the comment box. If you can answer this question, please type it in the comment box. Hello, we got Golden Nugget. We have Momo, Jewel, Mr. Walker, Isaac, Sacred. Good to see everybody. Good to see you all's names. Type in what you think energy is. Hey, Jalen. Hey, Miss Green. Alright, so at this point you should be typing in what is energy. I'm waiting to see some answers in our comment box. Start typing in some answers, please. Does anybody know what energy is? If you do, type it in. If you don't, put a thumbs down. Momo said it comes from heat. Okay. Anybody else? Momo, would you care to go live with us, please? Alright, so energy is a power which comes from sources. Absolutely. It comes from various sources.
Hello.
Hello, Momo. How are you?
Good, how are you?
I'm great. Thank you for joining us. So some of your classmates are saying that energy is a power which comes from various sources. Would you agree with that?
Yeah.
Okay. And what did you type in, Momo? You said it comes from heat?
Yeah, I said that energy is a kind of type of source and it comes from heat most of the time.
What you say?
I said energy is a source and it comes from heat.
It could come from heat. Okay. Energy, Jalen said energy is when it goes into heat or when you put force into an object. We'll see. Miss Green says the ability to do work. So Ms. Green helped you all out. You all were given specific answers. Take a look at this, Momo. Can you read the first bullet, please?
Yeah. Energy is the ability to do work, and that energy comes from all sorts of sources, such as the sun, wind, petroleum, and muscles inside our bodies.
All right, so energy is the ability to do work. That work could be moving back and forth. That work could be providing a light source. Okay, energy is the ability to do work. The second bullet basically says that energy cannot be created nor destroyed. Okay, energy cannot be created nor destroyed. If that's the case, how does energy work?
Um, well, they're kind of like they probably bond together with other, materials and stuff. Because if it's not created nor destroyed, then it's like it doesn't. It stays there. It's the same thing.
So if it can't be created nor destroyed, it's just going to be transferred from one thing to another.
Yeah,
Does that
compound.
make sense?
Yeah.
All right. Give me a thumbs up if you all understand our answers to the warm up. Give me a thumbs up if you understand our answers. All right, Ayana. All right. So that's what we're gonna do next. Here is our objective.
Okay, so by the end of the by the end of a lesson, scientists will be able to dif, different. I can't say
Differentiate.
differentiate between kinetic and potential energy. Describe the relationship between potential and kinetic energy.
All right. So that word is kinetic.
Kinetic.
Okay. And potential. So by the end of the lesson, you all should be able to understand the difference between those two. Okay.
Mm-hmm.
Here is our agenda for today. The plan, of course, we just did our warm up and our objective. We're going to introduce you all to kinetic and potential energy. There is a simulation slash videos on MOSA Max Science, and there is an exit ticket. So that is the plan. Okay.
Yep.
All right. Here is some science vocabulary that you will need in order to be successful. All right.
Yep.
So screenshot this. I also put this in my Insta story. So this particular slide is in my Insta stories. These definitions and these vocabulary terms will help you complete the assignments that is in your packet. Okay.
Okay.
And also, if y'all take a look where I actually pinned something. It says kinetic energy depends on the speed and the mass of the object. I will say that you will need that definition in order to be successful within your packet. Okay?
Mm-hmm.
That's why I pinned it. Let me get a thumbs up if everybody understands what I just said. Let me get a thumbs up. All right, young boy Reek, thank you. All right. Okay, so moving forward. Let me show y'all something right quick. At this point, you all should have this sheet in your packet, correct?
Let me see. Yep.
This should be your first sheet in your packet. All right. So today, of course, I'm not going over these questions word by word, but today's lesson is centered around this sheet. Do that make sense?
Yep.
All right. So just want to go back to where we were. All right. So What is energy? What's getting ready to happen is we're about to take a look at a Mythbusters video.
Mm-hmm.
And within this video, they're going to do an experiment on a water heater. They're actually going to make a water heater explode.
Oh, wow.
Okay?
Okay.
So your job is to watch this video
Okay.
and just try to pay attention and jot down some things that you see is happening as it relates to energy.
Okay.
Okay?
Mm-hmm.
If you understood what I just said, please give me a heart emoji in the comment section. All right.
Juggling is called misdirection. And no matter what level you are in magic, we got stuff here for you.
Move, Louie.
A message from one of the lead members of the White House Coronavirus Task Force.
This is not what we're talking about. 1 second.
Good evening.
Whew.
The buildup of steam under pressure can cause many things to go off. But how about a water heater bursting right through your house? To mimic a real-life situation, the roof of the house is inspected to California Building Code specifications. And the water heater contains no explosive. You turn on the power, hunker down, wait. Feel ready? Everyone's in position, camera all roll? Yeah. Got a nice little red house out there sitting out, like everything's rosy. Rosy on the outside, but roasty on the inside. Okay, everybody. We're at 300 psi. That's twice the tank rating. Keep your eyes peeled because it'll go in there. As the pressure inside the tank mounts, so does Jamie and Adam's heart rate. 315 psi. This is killing me. 320. 10 seconds. 325. This is excruciating. That's kind of stress on a regular basis can't be good. No. Shortening our lifespan. We're going to make it 350. Whoa! 10 tears through the roof like it's tissue. You could practically have a 3-course meal while you're waiting for it to come back down. Look at the house. What house? What's the house? I don't know what to get talking about. This actually surprised me. The house was no hindrance whatsoever to the rocket. It probably would have gone through several houses like this before it stopped going. It's like a fairy tale come true. The water heater puffed. It puffed, and it blew the house down. It just goes to show you, there's danger everywhere. Did you know what was lurking in your basement? Well, the guys expect what's left of their once charming home.
All right, Momo. So what actually happened in the video?
I could barely hear it, but I was paying attention, so I'm gonna say that I guess they were talking about like how how the heater might explode because of the mass and the everything.
Because of the mass and everything?
Yeah, because they said they was gonna use kinetic energy to determine how to make the water heater explode.
Okay. Um well, They did something in particular in order for it to explode. I'm sorry that you all couldn't hear it, but what I did was I actually put this video on our canvas, and you all will be able to look at the entire video and answer questions that relate to this video. But long story short, this is all about energy and how the energy was built up so much that it didn't have any choice but to actually explode. Okay, I don't want to give you all of the answers and give it away, but that is actually what happened within the video. Okay. I did not play it for the entire 4 minutes for the sake of time, but you all have access to this in Canvas. Okay?
Where's my
Anybody else want to share their thoughts? Hey, Isaac, how are you? All right. Let's get back to our lesson. I wanted to introduce this to you all and then sort of bring it full circle. There's the reason why I showed this first. Okay. All right. So energy, we said, is the ability to do work and make things happen.
Yep. Which of these items have energy? What is your evidence?
All right, let's back up real quick. Up here, you probably can't see it. It says motion, heat, light, and sound are clues that energy is present. Now, Momo, please read this, the white part.
Which of these items have energy, and what is your evidence?
All right, so right here is what? What do we see?
Apples.
Apples. All right, so people are just commenting about the heater. Heater might explode from how much heat or energy is inside of the water. Absolutely, Grace. Okay, what is your evidence that these apples have energy? Anybody can type in for us, please. Anybody know?
I don't think apples have energy.
You don't think apples have energy?
I mean, I don't know.
Do you all think apples give you energy? Give me a thumbs up if you think so.
Oh, okay.
I'm waiting for some answers here. Okay. Mr. Reek said they give us energy. How do we know?
Because of the vitamins, how healthy it is.
What if this was pizza? What if it was pizza or a hot dog or?
No, that's unhealthy. That's junk food.
So you're saying unhealthy food doesn't give us energy?
Yeah. Unhealthy, anything that doesn't have like vitamins or anything to strengthen up your immune system it doesn't have energy.
So what if I didn't eat for 5 days and the only thing available to me was a hot dog? You're saying that won't give me energy either?
Oh, it will, because food gives you energy. Oh.
Okay. All right. Food gives us energy. Okay. What about these young ladies playing the violin?
Yeah. Because they're moving their arms.
They're actually moving. When we talk about kinetic energy, that means the object is actually moving. Okay. What about here? This is a campfire.
Yeah.
Miss Green said that the energy is conserved. Yeah, it is conserved. So, for instance, if we were to eat dinner, then we relax and go to bed, we are conserving our energy. However, when we get up in the morning and we go to track practice, we're going to use all of the energy we just ate from last night. Correct?
Yeah.
All right. All right, Nia, just follow along with us. Okay? And I'll bring you up to date in a few. Okay? What about this car here?
Yeah, car uses energy.
How so?
When you put like gasoline in it and it starts to go, like it's moving, it's using the gasoline for energy to like move.
Very good. Thank you, Tamani, for helping her out. Yes, Momo. So you use energy, but this particular car does not use gas. Can you see
Oh,
closer?
oh, it's one of them electric cars.
Yes, this one uses electric, so it has to be plugged in
That's the
for a certain
charge,
amount of time. It has to charge, absolutely.
like a thing.
Okay. So this type of car uses electrical energy. Okay.
Mhm.
All right. What about this huge boulder right here? Look
I
at that.
mean,
Woo.
yeah, if you like push it, yeah, if you like move it, yeah, but if it's just
So
sit, if
is
it's
it
just
actually moving right now?
no,
No, it's not moving. So at this point, that would be potential energy. Okay. If it was moving, it would have been kinetic energy. All right.
yeah,
Someone's saying it's electric. Yes, it's electric. All right. Let's talk about potential. Potential energy is energy that is stored. See that?
yep,
Energy that is stored. Like I was saying a few moments ago, if we were to eat our dinner, whether it's a salad, a cheeseburger, something healthy, we are storing energy in our bodies to be used at a later time. Okay?
mhm,
So take a look at this picture here, this bow and arrow.
yeah,
Right now, that bow and arrow is not moving. Okay?
yeah.
So when a bow is pulled back, it has potential energy. It has the potential to actually move. Okay?
Oh, okay.
What's another example that has potential energy?
Hair,
You said hair?
yeah.
How so?
Cause you know how like unless you're moving, your hair moves sometimes, or like a bottle or something like that, or water, or
I want you to think about, look up in terms of what this bow and arrow is doing. He's actually pulling and stretching it back, right?
mhm,
What could we pull and stretch back that's in our homes?
a rubber band.
Yep. So a stretched rubber band would be an example of potential. Miss Green says a book on a table. Absolutely. The book could just be laying on the table, doesn't move. It has the potential to move, but it doesn't. How could we make that book move?
By flipping it, like
Say it
opening
again.
it, opening it.
Open it, flipping it, sliding it. All when you start to slide it, when it starts to move, what type of energy is that?
Kinetic energy.
Kinetic. Very
Kinetic.
good.
Kinetic. Okay.
So we have Jalen said the roller coaster when it's at the top. Absolutely. When the roller coaster is at the top of the hill, you know how you first start off at the amusement parks, and the roller coaster goes at the very, very top, and it stops moving.
Yeah.
At that point, it's at its like highest potential. It's not moving at all. It has built up so much energy, and once you start going down the hill, that's when it is kinetic. Very good. All right. Here's another example of potential energy. You see right here, we have, you see this right here?
Mhm.
Trying to give you all a better photo. This one is a compressed spring. And
Mhm.
this one here is, both of these are compressed springs actually. All right.
All right.
The one in the middle,
That's a battery.
battery. What's inside batteries? Do we know?
Another battery.
Nope.
Um.
There are actually chemicals inside batteries.
Oh yeah, they do.
Right now, is this battery being used?
No.
No, right now is using potential energy. However, if I was to put it in my remote control and I'm flipping channels, am I using the battery?
Yeah.
Absolutely. Okay. And last but not least, we have this balloon.
Mhm.
Okay. How can we make this expanded balloon become kinetic energy? What
Blow
could
on
we do?
it.
Say it again.
Blow on it, like making like, and it moves.
You could, but what would be the simpler way to do it?
Carry, move it
Because
around.
right now it has air in it.
Yeah.
What would be the simpler way to do
Um. I don't know.
it? Well, right now we have the air in it. It's just, excuse me.
It's just floating, so you like tap it.
It's just floating. You could tap it. You could also. It says it's filled with the gas. Let it fly. It all depends on what gas it is. So if it has helium in it, you could let it fly away. But if it has just our
Oxygen.
oxygen, well, carbon dioxide in this case,
Yeah.
it won't go anywhere. But what you could hit it with a pen, and then the balloon will go everywhere. Correct?
Yep.
All right. Let's move on. Are any questions thus far? All
Nope.
right. When it comes to kinetic is the energy of motion. Can we see that? Kinetic is the energy of motion.
Mhm.
When a pulled back bow is released, the moving arrow has kinetic energy. Okay?
Yep.
I'm trying to get this together, y'all. I'm sorry.
You fine.
Synonyms for kinetic are active and lively. All right? What's another example of kinetic energy? Someone put it in the box for us, please. What's another example of kinetic energy?
A car moving.
Yep.
Drawing.
Moving your hands, okay.
Running.
Yep, running. Mm-hmm. What
Typing. Moving your fingers.
typing? What about if I had a row of dominoes and I plucked one and it made all the other dominoes? It was a chain reaction. Is that kinetic?
Yes.
Absolutely. Okay, kicking a ball, all those are kinetic. Ball rolling down the hill, correct. Very good. Thank you, Miss Green. Thank you, Taymani. Thank you, Jalen. All right. What is another example that has kinetic energy? We have these kids running on a soccer field as they play soccer. Okay. We have this race car traveling around a track. You see that?
Mhm.
Mm-hmm. Energy can be transferred from one type to another. So right here we have potential energy. Is this bow actually moving?
No.
Not at this point. Okay. Where does all the energy go once this bow hit the ground?
Forward.
Huh?
Hold on. Say it one more time.
So right here we have this bow and arrow has gone from potential. Once she pulls it back and let it go, once it starts moving, it becomes kinetic. Okay.
Mhm.
Once this bow hits the ground, what type of energy or what happens to it?
Potential.
Say that again.
Potential energy.
Oh, potential energy. Very, very good. Because energy can be transferred from one thing to another.
Yeah.
Okay? All right?
Mhm.
Take a look here. We have two balls. We have a blue ball and a red ball. All right? I want everybody that's on this live with me right now, I want you to give me a thumbs up if you think the ball on the right has more energy, and a thumbs down if you think the ball on the left has more energy. So give me a thumbs up if you think the ball on the right. So give me a thumbs up if you think this has more energy. Give me a thumbs down if you think this has more energy.
Renegade.
So we're saying, according to you all, everybody is saying that this ball, you're saying that this ball has more energy than this ball.
Yeah.
Is that correct, Mama?
Yeah.
Is that what y'all saying?
Yeah.
Okay. And unfortunately, everyone is incorrect. Everyone is incorrect. I want y'all to take a look here.
I knew I should have picked the blue ball.
Listen, the blue ball. Look how high this column is.
I know, it's just because I thought since it's shorter, it's gonna like move further a little bit because it's short. I don't know.
Okay, that's a good argument, but I want you to think about this. These two columns, one is higher up. The blue ball is higher up, so it has more potential energy. So I want you to think about this. And Jalen brought up a good point when he talked about roller coasters. Okay?
Mm-hmm.
Think about this at the top of one roller coaster, and this is at the top of the other roller coaster. Okay? As we're traveling up, it's getting more and more steep. You understand that?
Yeah.
If it's more steep, by the time it turns around and goes down, it's going to create more and more kinetic energy. So the higher up, the more potential that it is. Okay?
Yeah.
Give me a heart if you understand that concept. Remember, the blue one has more potential energy. The blue one does.
So
Give me
higher,
a heart.
So let me get this. So the higher it is, it has more potential energy.
Correct.
Okay.
The higher up.
A higher up. Okay.
Okay.
All right.
All right. I thought blue was thumbs up. No, blue was thumbs down, I believe. Yeah, blue was thumbs down.
Yeah, you said blue was thumbs down, red was thumbs up.
All right. Let's move on. Take a look. Who has more kinetic energy? We have Tanya. She's running 3 miles per hour. Or we have Tamara. She's running 6 miles per hour. Which one or who has more kinetic energy?
Tamara.
Type in the name for me, please. You too, Momo. Is it
Alright.
Tanya or is it Tamara?
Okay.
Type it in. Is it Tanya or is it Tamara? All right. Yes. We're getting the right answers. Tamara has more kinetic energy. Why?
She's moving faster.
She has more miles per hour. Okay.
Yeah.
All right.
Yeah.
Let's take a look here. Which spring has more potential energy? Which spring has more potential energy? We have spring 1. Spring 1 is only working with 10 pounds. Spring 2 is working with 100 pounds. Okay? Out of the two, which one has more potential energy? I need you to type in 1 or 2? Okay, somebody said spring 2. Spring 2, it has more mass. Spring 1. Okay, so we there's 2 people that said spring 1. The correct answer, you're ready for it?
Yeah.
The correct answer is spring 2.
Who
So
I thought you
listen,
was gonna say spring 1. I was gonna be like, how?
listen. Spring 2 is more compressed, so it has more potential energy. Look how this is, okay? So if we were to let this go, it would go really, really far compared to this. When we talk about compressed, we're talking about how close the springs are to one another, okay? It's
Yep.
more compressed, it also has more weight, okay? Going back to what I said, if you take a look at where I pinned, kinetic energy depends on the speed and the mass of the object. Keep that in mind. Okay? Let's go to the next picture. Which ball has more energy? It says the balls are exactly the same height. Okay? So the balls are the exact same height. However, one is at what type of energy is the blue ball right now? Is it
Kinetic.
kinetic or is it potential?
Kinetic.
Thank you. So the blue ball is at kinetic. What about the red ball?
Potential.
The red ball is at potential.
Mm-hmm.
So which one has more kinetic energy? Is it the blue or the red?
The blue.
Okay. However, they're at the exact same height. What can we say about potential at this particular point?
Uh, I mean, the red one is potential. It's not really moving unless you move it at the same time.
Okay. So answer me this, y'all. Do they have the same or different amount of potential energy? Type that in. Put same if you think it's the same, or type in different if you think it's different. So I'm hearing different from Momo. Okay. Different. Anybody else? Type in same or different. Different. All right. So I see some of my kids are a little confused. Let's unconfuse my kids. Okay. So it says both balls have the same amount of potential energy because they have the same what, Momo?
Same potential, like
They're at the same level. Right?
level.
They have the same level. So they both have the same amount of potential energy. However, the blue ball has more
Kinetic energy.
kinetic energy because it was already
Dropping.
it is dropping. Okay? All right?
Uh-huh.
So they both have the same amount of potential energy, but the blue ball has more kinetic energy.
Oh, I get it.
Do you give me a thumbs up if you get this concept, please? Give me a thumbs up if you get this concept. All right, so we have 2 people that get it, 3 people. Thank you. 4. All right, let's move on. All right. How is energy transferred? Where does all the energy go once it hits the ground? Okay. So right now we have This blue ball, is it moving or is it staying still?
It's staying still.
So that's why it is all what?
All potential.
All potential. Now, take a look at this green ball right here.
Okay.
We have a little kinetic, a lot of potential. Why is that?
So I guess when you when they pushed the green ball, it stayed in the same place, but it was still moving at the same time.
Yeah, well, it don't stay in the same place, but it's not too far from the top.
Yeah.
That's why it says it has a lot of potential and a little kinetic, because this space between here, there's a small space, but it's still moving.
Yeah.
We have a little kinetic, a lot of potential. Okay? What can you predict is going to happen as we keep dropping balls further and further down? Will this change or stay the same?
It will change. Or no, it will stay the same.
You sure?
I don't know.
You don't know?
Maybe. Maybe.
Okay, I need you all to type in the box. Will it stay the same or will it change? As we continue to drop balls down here, will this change or stay the same? Type that in the box, please. Change. Okay, absolutely. All right, so take a look here. We are halfway through the point, Momo. What color is that? Orange?
Yep.
All right. Orange, yellow, orange. So right here, we're halfway between this point. So we have some kinetic and some potential. And last but not least, we're going to have all kinetic.
Also, as it goes more down, it would change. So
it's very good. So it's going to change from what to what?
It's going to change to all, to a little bit, to some, to all kinetic.
But it changes from potential to what?
To kinetic.
Very good. Very good. Okay. And that all depends on the position.
Yeah.
Any questions so far? We good? All right. So take a look right here, please. I need you to screenshot this right quick.
Okay. I'll screenshot it.
All right, so this is actually your exit ticket, but I want to go over at least a few parts of this. All right. For your exit ticket today, it says write a description of what happened in the exploding water heater video. Use the concepts we learned today. We learned energy, potential energy, kinetic energy, and transfer of energy. I need you all to think about the video that we watched and sort of tell a story, but use these terms. Okay? So for an example, those guys on this Mythbuster video, they put energy into the water heater by connecting it to an electrical outlet. Do you think that is wise?
Oh, no.
No. Because anytime water and electrical outlet come in contact with one another, that is no good. Right, it's no good. Okay, so that's what they did. Okay, and when they connected it to the electrical outlet, the temperature and pressure in the water heater increased. Okay, and as it increased, what type of energy was happening? Was it potential or was it kinetic?
Kinetic.
No, as it was increasing.
Oh, potential?
It was potential. Okay. When the water heater exploded, that kinetic energy, when the water heater exploded, that potential energy turned into what?
Kinetic energy.
Kinetic energy. And that's why the little but the small little house that they built, that's why that actually blew up. It was so much energy inside that it had to be released. Okay?
Let it go.
Let it go. Exactly. Exactly. It will make more electricity, so it can also make it explode. All of those items. But what I want you all to do, I want you all to be sure that you go on Canvas and look at the full video. Be sure that you answer your questions, your warm up and your exit ticket questions. And make sure you describe what actually happened using 3 to 5 sentences. Okay? Keep in mind, I want you to take a look at the bottom where it says kinetic, where what I pinned, kinetic energy depends on the speed and the mass.
Mm-hmm.
Keep in mind because you're going to need that in order to answer your packet. So, let's go here right quick. There we go. So we take a look at our packet. I know most of us have questions about it. Oh my goodness. There we go. The first question is, we see a person throwing a baseball, correct?
Mm-hmm.
All right. Now, the question says, explain how this picture is an example of kinetic energy. How is this picture an example of kinetic energy?
The ball is in motion when the
Mm-hmm. The ball is the ball the only thing in motion?
no, the man's leg and his arm.
Absolutely. Okay. Those are the type of answers we are looking for this one. So we have the ball is in motion because the baseball player, well, the pitcher is actually throwing, he's using his body to throw the ball. Everybody understand that?
Mm-hmm.
It says kinetic energy is the energy of motion. I want you to underline that, please. That second sentence.
Mm-hmm.
Underline this right here. Question number 2. What factors affect the energy of the ball? Yeah, we know the pitcher is throwing a ball, the bouncing ball. No, the man is not running. The man is actually at the mound and he's throwing out a pitch, Miss Green.
His body is just like
His
moving.
body is just in that forward type motion after he lets the ball go. Okay? Yeah. So he's not running. All right. So, question number 2, what factors affect the energy of the ball?
How fast it goes?
Yes, what affects it? If you take a look at my pinned statement, Gracie, we are on week 5, and it should say
It says grade A science week 5, April 20 through 24.
This is where we are, Gracie.
It should be in your big thick packet that they gave us.
We're in week 5. Okay.
So it says energy depends on the speed and the mass of the object.
Of the object. So that would be the factors. It would be the speed. Energy depends on speed and the mass.
Okay.
Basically, the more mass and speed, the more the kinetic energy. Okay?
Mm-hmm.
The more mass and speed, the more kinetic energy. All right? So, you all should, number 3, what change could be made to give the ball more energy? I just helped you out with that one.
Less mass?
What could
Or
give the ball more energy? What could happen? What needs to happen?
when you hit the ball, or when the ball is coming towards you, you hit it with the bat, and then it flies in the air.
But think about speed and mass. Think about speed and mass.
So less mass, more speed.
Not less. It would be
More.
more mass and more speed. So
Okay.
if you give the ball more mass and more speed, you're giving it more energy.
All right. More mass and more speed.
Okay.
Mhm.
Um,
Oh my
Jalen
head.
said throwing it harder and more seated. So no, it's more mass and more speed. More mass and more speed. Okay. All right. Are there any questions about today's lesson?
Nope.
Give me a smiley face if you are if you understood today's class. Give me a smiley face if you understood today's class. All right, Momo. That was one. I need some more smiley faces, please. More smiley faces, please. All right. So, we're going to stop here, but we will continue this concept on Wednesday. What I want you all to understand is that quarter 3 is over and done with. And if you haven't completed your assignments in Canvas, you need to do so as soon as possible, because us as teachers, we are getting your grades done and your grade book and in preparation for quarter number 4. So please be mindful that you all are turning in your assignments. I want to thank all of my kids who are on here every Monday and every Wednesday and doing their assignments and doing what they're supposed to do. So I'm very proud of you. Okay? Very, very proud. I will talk to you all later. If you have any questions, please feel free to send me a DM or send me an email. Okay? Talk to
Bye,
y'all
Miss
later.
Tate.
Bye-bye.